It's a pleasure to be here. I've been on the Bonus Advisory Board since its beginning, and actually I was here last year about this time, and I had underway a process which I couldn't speak about very much because I was under investigation at the time. But I subsequently was appointed to a presidential commission to look at this oil spill, and that's what I wanted to talk about today and give you a sense of some of the science that's gone into it, but also some of the broader implications of policy and how science informs it. First of all, this oil spill occurred in the Gulf of Mexico. You all know about the Gulf of Mexico. It is the sea off of the United States and Mexico and Cuba, which compared to our Atlantic and Pacific oceans doesn't get as much attention. And it is a very big body of water. It's 1,500 kilometers across. The deepest spot is about 4,800 meters. So it's an ocean, basically. And you can see the location of this well where the spill took place was on the deeper part of the continental slope, about 1,500 meters of water depth. And so it posed a whole sets of new issues and problems that I'll try to give you an understanding of. One of the things you might not be aware of, in fact, most people in America and the United States are really unaware of, is the extent of development of offshore oil and gas in the Gulf of Mexico. It is huge. There are literally 20,000 or so structures and platforms just in the U.S. waters. At any given time in the U.S. waters, there's 30,000 people who are living and working in this environment to produce oil and gas. And it has this tremendous network of pipelines and wells and the like. And the area that's kind of reticulated in the deeper water, those are areas that have already been leased for exploration and development. So you can see, and I'll tell you a bit more about that, it's really moved into deep water. But I also wanted to point out that there's oil and gas production in Mexico, where there was an oil spill some years ago, down here. And then also there's plans for development of offshore oil and gas in some deep water in the straits here off of Cuba. So this is an international challenge that we have in this body of water going forward. The Macondo well, the Deepwater Horizon was the drilling vessel that was drilling the well, so it's often called the Deepwater Horizon spill, but it actually was from the Macondo, named after a fictional a town in South America that was a place where you lost hope. And so it was aptly named. It occurred a little over a year ago, on April 21st. 12 men were killed in the explosion. Tremendous ball of eruption of natural gas came up the riser and caused the explosion. The generators on the drilling ship, once they started to bring in the methane, natural gas was just racing, and finally it just caused a massive explosion. But in addition to that, of course, as the platform collapsed and the riser was broken, it unleashed a gusher of oil and gas coming out of a deep water well for the first time ever, really, at this water depth, with little capacity to try to control it and deal with it. So it took literally almost 3 months to contain this blowout. So it really was a major event in the U.S. because it riveted attention every day in the news, particularly when they started showing these live videos of the oil just coming out. It was a sort of a hopeless message that everyone saw. So as I said, when I was here last year, I had already been contacted. I got a call. Back up a little bit. I actually worked in the Gulf of Mexico before moving to Maryland 21 years ago. And I worked on offshore oil and gas issues. I worked in the Gulf of Mexico. So this was the reason, I think, that I got this call. Plus my experience on Bonus Advisory Board was the reason I got a call in late May. I was actually watching this whole spill and becoming frustrated and concerned like everyone else. Talked to the press a little bit, was put kind of out of the loop, and at that time the news was that BP was going around and hiring scientists to be on their side, and so I was commenting to my wife. I said, I don't know how no one's called me yet, but I just have a feeling that, that because of this spill, I'm going to become rich or famous. And she said, knowing you, it's not rich. She was right. So I got a call, and it was my office, and my secretary contacted me and said, I think you ought to return this call. It's from the White House. I said, okay, I returned it. It wasn't the president. It was one of his assistants, many assistants, who said, the president would like you to serve on this commission. I said, oh, how do you say no? So I agreed to do it, and but not just there yet. We have to investigate you, and we have to do all the vetting and so on that's required. And it was an impressive vetting, even to the point of asking me questions about my speeding tickets, 20 years, 15 years ago, and all sorts of things of this sort. It resulted in my having the discovery that I didn't know. My wife had bought this, that I actually owned stock in the company Transocean that was drilling the well. So I had to sell that stock. I also happen to be on the board of trustees of an organization in the U.S. called the Consortium for Ocean Leadership, which, among other things, has the contract from NSF to manage the ocean drilling program, the International Ocean Drilling Program. And I had no idea, but the contractor that operates the drilling vessel, the Joyde's Resolution, is actually co-owned by Transocean. So I had to recuse myself from service on that board and so on. So here we were. We had only 6 months to complete the job. It was a board commission composed of only 7 people. I was really the only scientist, or at least environmental scientist. We had another member who was the dean of engineering at Harvard. So I had to cover a pretty broad territory. But I also learned a lot about speaking to people who are not scientists, and as they begin to think about the policy implications. So just to give you example, this is obviously when we delivered our report on January 11th. We had only 6 months to do it here in the White House. This is the Roosevelt room in the White House. There's the president and a few of his cabinet officers and the like there. This gentleman was a former senator from Florida, former governor of Florida. He was the head of EPA, the Environmental Protection Agency under the first George Bush. He's the president of NRDC, a major environmental group, vice president of National Geographic, the former lieutenant governor of Alaska. So it was a very diverse group, and we had to kind of analyze this, very technical sets of issues and questions, because the focus of our effort was to find out what went wrong. What were the deep causes, not only the proximate causes of the explosion and the blowout, but what were the root causes? What are the things that led to this? And to make recommendations to minimize those risks going forward, and also to make recommendations about what this meant in terms of the nation's energy policy as it relates to offshore development. We were specifically told by the president, a little bit in the executive order that created this, but very directly to our co-chairs, that I do not want you to rewrite our national energy policy. Stay away from that. Also stay away from the legal liability issues. So those were the constraints that we had. The reports, and I commend this to you, this website's still up. We went out of business in March, but the website's still up and active, and it has included in it our final report, this thing called Deep Water, as well as a very detailed forensic analysis in this report, as well as a whole bunch of graphic visualizations, videos of our numerous hearings and the like, staff working papers that go into great length and detail. A really tremendous resource there. This report has actually been reviewed by book reviewers, and favorably, actually, for a presidential commission. It's actually pretty reasonable. Riveting was actually a word that was used in describing our description of the accident and the things that led to it. So it's worthwhile looking at. They're all available. You can get them Amazon.com, but you can also get the PDFs off of the website. Very simply, we don't have time to go into this. This is not only a lecture, this is a short course if it went into in detail. The problem was caused by a poor job of cementing the base of the well. This was a well that they had drilled to the maximum depth that they were going. They were basically going to temporarily abandon the well and come back in and re-enter the hole and produce gas and oil from that site at some point in time. So they were closing things down. And what happens when they drill, now mind you, this is 1,500 meters below the surface of the Gulf of Mexico, and another 3,000 meters below that is down into the earth that this well is. So one of the things as you'll see as we go into deep water, these deeper formations, the big challenge is the formation pressures. Very high formation pressures, a very risky situation that you've got to try to manage. And the way that's managed is by pumping drilling fluid. This is a heavy suspension that's calibrated in terms of its weight and the column height and so on to exert just enough pressure to keep any high pressure oil and gas from coming up the well, but not enough pressure to break the fracture of the formations. And so that's what they're trying to govern all the time. So they had done that, and then they were trying to cement the bottom of this well, and they were using, because of the problems they were having, they were using a special low density formulation of cement that had lots of nitrogen gas in it. And so you want it set so that the little bubbles are all there, evenly distributed. And you don't want it, if you don't get it right, the bubbles can migrate up and create little escape pathways, and that's what apparently happened. So they had a very poor design coupled with the cementing job, high risk, a lack of proper testing of the cement. And then at the end of this, what they do is once they cement it, is that they test the pressure. So if they draw a negative pressure, if all of a sudden the pressure comes back up, it means you got a leak somewhere. And they did that 4 times, and they ignored the result and tried another approach, which they seemed to think worked, and went on with business. Then they removed a lot of this drilling fluid, which is the pressure that keeps the thing down, to try to close the well off, and they lost it. It came up through the well, through the blowout preventer, which sits down on the seabed, which can be closed off in a number of ways. But one of the final solution is to shear the casing, just with a ram that cuts the casing. By the time they activated that, it was too late. There was gas already in the riser. There are 1,500 meters of riser, gas rising, expanding exponentially as it comes up with the force of a jet engine coming out of the top of that well. It also blew all kinds of stuff, gas, oil, sand, you name it, through that blowout preventer that damaged the gasket. So the blowout preventer, when they did activate it, it didn't work.